Hello, good afternoon. Amos Peter is my name, and you're welcomed to this lecture. But before I go on, permit me to share my screen with you. In this class today, we shall be talking about introductions to computer architecture and computer organization. And in this class, we shall attempt to define and explain what computer architecture and what computer organizations are. We shall also attempt to find out what computer architects and organizers have in mind right from the onset, whenever they're set out to carry out the task of computer system design. And then we shall also briefly see the differences between computer architecture and computer organization based on certain important indicators or factors. Now, basically, what the computer architect tries to achieve. Now, basically, computer architects always try to take an application. And by application here, I mean, for example, taking an internet browser, which could either be your Mozilla Firefox or your Google Chrome, or maybe wanting to play a video, making use of a VLC media player or the Windows media player or any of the players. Or maybe perhaps a user wants to calculate a spreadsheet application such as Microsoft Excel. Now, computer architects wants to pick any of these applications and then see how such applications could be mapped down to physics. And by physics, I simply means the computer owns native language. We all know that the hardware or the bare metal of the computer system actually only understood only binary digits known as the bits. And it is at this level that you have the electrons, the photons bouncing back and forth in order to carry out the tasks of information processing. Now, basically, this is what computer architects hoped to achieve. And they do that by designing, putting in between this long gap, what we refer to as a series of layers of abstraction. And you can see that between the application layer and the physics layer, we have 9 other layers. So just like I said from the beginning, of course, from our theoretical knowledge of physics, where we have the laws of Ohm's, Kirchhoff's law, the law of quantum mechanics, of course. With that knowledge, we'll then be able to build what we call devices, such as the transistors, the diodes, and the capacitors. And of course, it is these devices, when connected, that forms electrical circuits. And from circuits, we can build our logic gates. Then we can also subsequently build the register transfer level. Then we have the microarchitecture, what in other climes, it's also being referred to as the computer organization, computer organization. Then here we have the microarchitecture, which is also referred to as the big A architecture. The instruction set architecture simply refers to the set of all the possible instruction sets that any particular CPU or design could execute or understand. Then, of course, we subsequently have the operating system for any application to run successfully on a computer system. Of course, the operating systems will be the platform upon which every other application on a computer system can be installed. And of course, the OS serves as the overall system manager, as we all know. And of course, no application can actually be built or design without the use of a programming language. So the programmer makes use of a programming language of his or her choice. It could either be a Python, C++, or Visual Basic. And of course, before any program could be developed, an algorithm, which is a sequence of step-by-step way by which such an application or a task could be solved, will have to be developed. And then finally, we could have our application either in the form of a web browser, a media player, or a spreadsheet application. So in a nutshell, you could look at computer architecture as, the method or the way in which computer architects designed or developed these various layers of abstraction from applications to physics that enables us to carry out information processing efficiently through the use of manufacturing technology. Now, in the second slide, we shall see some of the about 2 or 3 conventional definitions of the term computer architecture and also computer organization. Computer architecture could be defined as a set of rules and methods which describes the functionality, the organization, and then the implementation of a computer system. You can see that these 3 words are very, very fundamental, and that's why they have been highlighted, with bold font. Now, an alternative definition of computer architecture is that you can picture computer architecture as a specification which details how a set of software and hardware technologies interacts in order to form a computer system. Now, on the other hand, computer organization refers to the operational units, the individual operational units of a computer system and their interconnections that realizes the architectural specification that has been, laid out during the architectural design. So in other words, you can see that computer architecture and computer organization are just like a side, 2 sides of a coin. In other words, you cannot do one without the other. They are intertwined. However, computer architecture duties are carried out first to lay down all the specifications regarding our system. And then, of course, it is the organization that implements what has been put into the architectural specification. Now, in the course of my definition that I said, in the broader sense, computer architecture could be seen as the design of all the abstractions and the implementation layers that help us carry out, information processing applications or to run them efficiently and effectively. Now, a definition of what an abstraction is very, very important at this point. So abstraction is actually a methodology that is frequently used in the science and engineering space. And the word abstraction refers to the act of representing essential features of a system without including the background details. And this tool is usually used to help reduce complexity while designing any system. And it helps us to do that optimally and more efficiently. So you can see that background details are usually are removed whenever we're trying to do any abstraction about any particular concept. Now, in the next slide, we shall see in a nutshell the basic differences between computer architecture and computer organization. And we shall do that looking at 5 important indices. The first one is when it comes to purpose. What is the purpose of computer architecture and what is the purpose of computer organization? Now, when we're carrying out computer architectural activity, computer architecture is basically much more concerned about explaining all the tasks or all the things that a computer system should do. While in the case of organization, we are much more concerned about explaining how a computer system achieves all the tasks that it has been specified to do. Now, in terms of target, computer architecture tends to provide about the functional behavior of a computer system, while computer architecture organization is much more concerned about the structure and the arrangements, while architecture is much more concerned about the functional behavior. Now, in terms of design, computer architecture deals with high-level design issues, such as the designs of, the CPUs, the designs of the logic gates, while in the case of organization, we're actually much more concerned about the data part between the CPUs and the memory, that's the random access memory, and so on and so forth. The actors in computer architecture are basically the hardware part, while computer organization is all about performance or speed or the efficiency. In other words, how will these parts here that have been designed, how will they be arranged or configured in order to have optimal performance? While in the case of order, of course, this computer architecture is designed first, while organization comes second in order to implement all the specifications that have been specified in terms of computer architecture. Now, basically, in a nutshell, that is what computer architecture and computer organization is all about as a way of introduction. And computer scientists and engineers engage in these activities in order to design faster, good, efficient, and modern computer systems, because it is only when you know how or the hardware of the computer operates and interacts with each other, then it is only in that way that computer programmers will be able to write softwares that will make optimal and efficient use of the system in order to achieve better performance. So I would like to hold on at this point, and I hope that the information I've provided in this short lecture has been very, very informative, and I would like to thank you for viewing. See you next time, and thank you.